Look at this absolute beast from JEE Advanced 2016. This massive expanded fraction looks terrifying. But first, let's condense those repeating ... terms into a compact product notation. Let's carefully isolate the numerator. To create a recognizable format, we factor out n over k from the parenthesis. Now we split the product. The product of n over k from 1 to n is simply n multiplied by itself n times divided by n factorial. Multiplying our leading terms gives us a massive constant, n to the 2n over n factorial. Applying the exact same logic to the denominator, we factor out n squared over k squared. This product evaluates to n to the 2n over n factorial squared. 1 factorial cancels with the leading term. Now look at the constants in both our expanded numerator and denominator. They are perfectly identical. They cancel out entirely. And just like that, the beast collapses into a beautifully clean fractional product. Taking the natural logarithm brings down our variable exponent, converting the infinite product into an infinite sum. Using the standard Riemann limit, 1 over n becomes dt and k over n becomes t. A quick substitution of u equals xt gives us our final definite integral. Applying the Newton-Leibniz rule, the derivative of our integral is simply the inside function evaluated at the upper limit x. Evaluating our options. Option A is false because the function is strictly increasing before x equals 1. Option B is true. Both inputs are in the increasing zone, so 1/3 yields a smaller output than 2/3. Option C is true, as the derivative is negative for any x greater than 1. And option D is false. Log of 4/10 is less than log of 3/5.